Okay, so I would bet, if you're having to watch this from home, we're moving into chapter 16. This is on electric charge. And again, electric charge plays a very similar role to gravitational mass. And you'll see that as we go through this. I bet you that you know number one, atoms are composed of protons, neutrons, and electrons. Could you fill in the little sign, like a sign? Is it positive, negative? Is it nothing for those? I bet you know that already. So take a moment. Which one's which? Yeah, the yellow blobs up there with the positive sign, those are the protons. You guys know that. You might not see the white blobs on the outside there. They have a negative charge there, but those are the little electrons. They carry a negative charge. And these orange blobs, neutrons, and they don't have any charge. So I'm sure you guys study that kind of stuff in chemistry, if not even just earth science and biology and stuff like that. So you have that stuff done. Now on the right, I did bring in some balloons. So I would like to, if someone's willing to, see if this balloon can actually be charged through friction with the hair. So you want to try this?
Oh, yeah.
All right, so what's your color?
The teal.
Teal. Okay, there you go. Now you got to blow it up. So Gabby's going to take this and rub this balloon against her hair, and we're hoping that rubbing action will separate some charges out. Now, ideally here, I know you guys can't see it really well on your diagram, but when Gabby rubs this against her hair, we're thinking that the hair will remain positive, and the balloon will acquire some negative charge. And so what we should see is that the hair would attract to the balloon. Would you be willing to show us that if it works? Okay, so you're going to rub that against the hair. We'll see if your hair develops a little bit of static cling. Now, I do have a Van de Graaff generator in the back that I'm not going to get out today, but I'll have that out this unit. Is it working at all?
Yeah.
Okay, give it a really good rub. Can you guys see the hair sticking to that? That's pretty good. Now, unfortunately, we cannot see the charges there, but there's evidence that there's charges there. That looks pretty good. Now, let's see. We need another balloon charge because we need to see if two balloons will experience some repulsion here. Anyone else willing to try this with the orange one? All right.
Okay.
All right, blow that up. You're gonna track that too. Do that. We're gonna see if these things actually repel from each other, because you guys know what do opposites do? Opposites attract, and what do lights do? They repel. So you guys already know those things. We're going to see if this actually works, okay? Now, if these will actually stick, I would love to see if this will stick to the wall. I don't know if it will. It looks like your hair is sticking to that pretty well. Did you get it? See, now your hair might be able to.
Mine's pretty dry, so it should.
Well, it works well when air is dry, because when air is humid, what happens to charge when air is humid? It leaks off into the water vapor that's in the air. So it works better on dry days. So I think Gabby found her new toy for the day. All right, Nathan, give it a good rub. Is it working?
Yeah.
It looks like, all right. Now, first, I'd like to see whether or not these things actually repel each other. Can we try that? So bring it over. Okay, so which side is charged? That side right there? Which side is charged right there? Okay, so we're going to try it. We're going to put these things. Oh my gosh, I can barely put these. Seriously, I'm like trying to push these things together, and they're like repelling. I mean, it's crazy. I mean, do you see that when I let them go? They just take off. It's crazy. All right, now will you take this and rub that again? I want to see if they stick to this wall. Would you try that there? Yeah, just pop it to them. Go. See if you can stick it. We tried it on the counter or on the cupboards. They didn't work really well. So see if you can stick it to maybe the glass. Try the glass window. No. Try it to the brick wall above the. Just try it.
No.
Hey, look! It's sticking. It's staying there. It's crazy.
Yeah.
Oh.
And this will stick.
Oh,
Look at that. Oh! That's scary. All right. How about it for these two? You want to keep it? You want to keep it? That's yours? All right. How about it? Give them a round. Thank you for doing that. All right. Oh my gosh. All right. Opposites attract and likes repel. And again, I bet you guys already knew that as well. So again, protons, neutrons, and electrons, and then opposites attract, likes repel. Charged objects may be created through some process. So how would you describe the process through which charge was created on those balloons when you rub that balloon against the hair? It starts with a W, rhymes with Merc, through work, right? So there's a work process. So you can do some work, and through like friction as a force, you can separate some charges. Those of you that are in chemistry classes could tell me what I'm trying to show here. A plus B turns into AB, chemical mixing. No, chemical reaction. So we can actually create chemical charges through a reaction process. And yet there's one more that I failed to write in here, so I'm going to add this to it, and I would like you guys to as well. There's another way that you can do this, and it has to do with something called polarization. And so this did not make it onto your note packet, but I would like you to understand what we mean by polarization. And I think probably the best way to show that is to give you guys a little bit of playtime. So what I'm going to do is I'm going to give you a link in your Google Classroom that allows you to play with rubbing a balloon against a sweater. First, I'm just going to demonstrate what it looks like. And then you guys have this on your classroom, 2 minutes, 3 observations. So let me first show you what it looks like when you open this. Okay, so when you open up your page here, you'll see static electricity fun, 2 minutes, 3 observations. So when you have this here, this will allow you to see what's happening as you start to rub the balloon against the sweater and stuff like that. You can have other balloons up here and do some crazy stuff. Anyway, you guys, 2 minutes, 3 observations, go. So when you're done, I'm going to ask for volunteers. What did you observe? And so 3 observations. See if you can record those somewhere, or maybe it's just in your head. The volume might be a distraction. Oh my gosh, is someone playing with the whiteboards? Shake them. When they take the whiteboard, they shake them? See? That's what I'm talking about. That noise. Yeah. Don't take that balloon with you, though. Oh, okay. Good. Last thing we need are balloons. Yeah, someone apparently. I mean, I chose green for Michigan State. They're doing so fantastic, so someone drew that for me. So that's apparently me. Troy? Troy? He said it was me.
That looks like you.
That does look like me. I'm not sure who Troy. Troy's my alias.
Oh.
Sometimes called my alter ego. Pretty good dress. Okay, you have 10 seconds. I'm going to have you share at least one observation with people at your table. What did you observe? So Finish it up, finish it up, finish it up. Make some observations there. All right, close it up and share with people at your table 3 things you observed, or at least one. Go.
So, I found out.
One observation that you made, someone willing to share. Dre's got it. Go. He's the only one talking right now. Everyone else is just. Wait, what you got, Dre? What's one observation? Go.
So I said the electrons, like the more you get on the balloon, it gets attracted to the sweater, but it still is attracted to the wall.
Okay, good. Then thank you for the observation. What's another one? Thank you. Don't be shy. Thank you, Ty. Go, Tyler.
Balloons repel each other if they're both charged.
So let's try that. And we saw that too, right? I mean, the balloons like separate out like that. What's another observation? Yeah, it did happen. What's another one? Yeah, thank you, Haley. Go. Okay, this is what we want. I want you guys to see with polarization. So on this, in your chemistry class, when you guys, let me reset this for a second. In your chemistry class, you guys talk about ionization. Would you agree that I'm sort of creating some ions here? Would you agree that I'm separating charges? That prior to this rubbing action, the sweater is neutral and the balloon is neutral? But when I separate charges, I'm actually moving charges from one thing to another, and I've created some ions. Now, just to make sure we understand this, what kind of ion would you call the sweater? It's a positive ion. How did it become positive? Because we removed electrons from it. So the sweater is now positively charged. We might call it a positive ion. The balloon has an abundance of electrons. Now there's charges that moved from one to the other. Now the other kind of charging is a process that Haley's pointed out is called polarization. This is what we mean by polarizing. So on the wall, in order for this balloon to actually quote unquote stick to the wall, is it's polarizing the charges on that wall. And what polarizing you can sort of think of an alignment. Instead of things being randomly oriented, we're going to take all the positive charges and sort of move them close to the surface of the wall, and the negative charges sort of polarize to go the other way. So I'm not technically transferring any charge on that wall, yet what I'm creating is what's called a polarized charge. So polarization is another way to charge something. So we would say that that wall is polarized. And you guys might study water as a polar molecule. Why is it polar? Why do we call it polar?
The molecular geometry of the water molecules makes it a slightly triangle shape, and so when they're facing each other, the hydrogen is slightly positive and the oxygen is slightly negative.
Sort of, I've heard it like this, an unequal sharing of electrons. Is that the way that maybe it's... Okay, so anyway, if it's unequal sharing, we would say that there's a slight polarized charge.
Yes.
Right? So we can say water is polar. Anyway, it is another way to charge objects. So not just through work, through reactions, but also polarization. Number 4, like energy and momentum, charge is blank. What would be a suitable word for that? Conserved. So charge is a conserved quantity. We're not creating, we're not destroying charge, but we can't transfer it, just like we can't create nor destroy energy. We can't create nor destroy more momentum. We can create and change momentum, but we're conserving it, is what I'm trying to say. So when we charge that balloon up, we're just transferring charge from one object to another. We're not creating charge. Okay. Now, this Millikin's oil drop experiment, sometimes it is talked about in chemistry. I don't know if you guys have done it. Robert Millikin did this oil drop experiment back in the early 1900s. What he determined is that charge is a quantized value. What that means is that it comes in discrete values. Another way to say that is you can keep subdividing charge into smaller and smaller and smaller values until finally you get to the smallest amount of charge that something can have. This is the experiment that he did. So he took an atomizer. An atomizer is just like a spray can for oil. And he sprayed that oil through this opening. Now, the charges, the oil droplets will become slightly charged through that process, sort of like friction. When Gabby rubbed the balloon against her hair, friction was enough to be able to separate charges from the hair to the balloon and vice versa. Same idea here. When the oil goes through that atomizer, the oil will acquire some charge. And all I'm doing here is just putting some charges on that so you guys can see that the oil might now carry a negative charge to it. It falls down into this opening, and so you put a little small opening in that top plate to allow just a few drops to go through there. Then he's studying those drops with a microscope. Now, he apparently did some other things to create some charges on this with some x-rays and whatnot, but probably the most important thing is that he created a positive and negative plate here for us to be able to suspend those charges. And so the idea here, I'm going to show you a video that sort of explains this, this experiment much better than I can do. And then we'll draw some diagrams for this over here. So let's see what this looks like. After this advertising. Okay. So that experiment is one of the great experiments